Hey everybody! So today's going to be our first day of notes. We're going to be looking at characteristics of quadratic functions, okay? If you have the notes packet, you should be following along. You should have picked that up in class. And if you are remote and don't have the packet for whatever reason, you can either print it out from Google Classroom or you can keep your own notebook. Like I said, I really recommend a graph paper notebook. Okay, I'm just going to go ahead and throw my name on here because obviously. And we're going to go to our first day, right? So we want to look at the features of quadratic functions, and specifically, we need to think about what that means in terms of parabolas, okay? Our goals today are we want to be able to define that list of vocab words there, and then we want to be able to apply those terms to a given parabola, okay? So we're going to start by graphing the function y equals x squared. We're going to start with what are called quadratic functions, and quadratic functions are anything with degree 2. So the biggest exponent is 2. So this is what makes it quadratic. Right? And let's just fill in a table of values. So I take my input x, -5, and I square it. Well, -5 squared is 25. -5 times -5 is 25. And you can do that throughout. So -4 squared is 16, 9, 4, 1, 0. 1 squared is 1, 2 squared is 4. 3 times 3, 9, 16, 25. There's some nice symmetry going on here. I think that'll be important later. I'm going to go ahead and I'm going to plot these points just like with like as if they're ordered pairs, right? So -5, 25, -4, 16, -3, 9, -2, 4, 1, -1, 1, 0, 0, 1, 1, and keep going. And we got a big, beautiful parabola here. This shape is called a parabola, and that's our first vocabulary word. And this is not a very smoothly drawn parabola, but we'll survive. All right. So a parabola is just the shape of a quadratic graph. So it's just this U shape, right? They can be U's, they can be flipped so they look like hills, but it's anything with this U shape, okay? The vertex is a special point on the parabola, and it is this point right here. This is the vertex, and our vertex is at 0, 0 here, but they can be elsewhere. We'll see, we'll take a look at that in a minute, right? So the vertex is the turning point of a parabola. Okay. Next, we have the axis of symmetry. Now, I just want you to remember that symmetry, that means we just talked about that the graph looks the same on both sides. So the axis of symmetry is the line that cuts a graph in half. So here, you can kind of see that it's symmetrical about the y-axis, right? This is my axis of symmetry. Remember, axis is just a fancy word for line. And it's always x equals some number. And in this case, 0, because that's my x coordinate here, right? So in our example here, it's x equals 0. We'll do some more examples of this in a second. So don't worry if you are not sure how that would apply to other graphs. We should know what x and y intercepts are. That's review. But remember, x-intercepts is where a graph, the x-axis, while a y-intercept is where a graph crosses the y-axis, right? And in this case, it's the same point, right? Like right there is my intercepts, so it's 0, 0. But we should be able to find those pretty easy. Okay. Here's the stuff that the students usually actually have trouble with. Increasing versus decreasing. okay? Obviously, increasing talks about going up, decreasing talks about going down. Increasing is the set of x values where y goes up. And if you look at here, at this graph, I always think to myself, if this was a graph of temperature, where would the temperature be going up? So as we go, so we start by going, if we read the graph from left to right, as if it were looking at it like a graph of temperature, it starts going down and then it turns around at the vertex and it starts going up again. And I say to myself, what numbers is that? Well, it's all of the numbers greater than 0 that do that. So it's for when x is greater than 0. It's to the right of the vertex, and that vertex is at 0, so it's when x is greater than 0. We can apply the same logic for decreasing, because decreasing is the set of x values where y goes down. And if I think about that in terms of my graph again, where is the temperature of this graph going down? Over on the left side of this parabola. So what numbers are those? That's when x is less than 0, because it's to the left of 0. Kind of think of it as like that axis of symmetry is dividing the graph in half. Which half of the graph is it? All right. Concavity. So concave up versus down is whether the graph opens up or down. A concave up graph is when a graph opens up. So our example over here that we have here is concave up. While concave down is when a graph opens down. So it kind of makes an N shape. Concave up makes like a U shape. Concave down makes like a upside down U, or kind of like an N. And the thing that students always have the hardest time with is domain and range, okay? So domain and range. Domain is the set of possible input or x values, while range is just the opposite. It's the set of possible output or y values. So when you're talking about domain and range, you think to yourself, you can either picture the graph. Here we have a graph. And what x values can I use? Well, I have an arrow pointing to the left, and I have an arrow pointing to the right. I have an arrow pointing to the left right here, and I have an arrow pointing to the right right here. So I'm going to hit all of the x values eventually. So my domain, you might remember this symbol from Algebra 1, is all real numbers. All real numbers is what that means, right? Range, though, we don't have an arrow pointing up and down, right? We only have two arrows pointing up, so I'm going to be limited. I'm going to reach a smallest value, and then that's the lowest value of the lowest output value of the parabola. It doesn't go any lower than that. And in that case, right, that happens right here at this point, right, at 0. So my range is y is greater than, it can be equal to 0 as well. So y is greater than or equal to 0. And that's my range. Okay, guys, so this is just a random example. So I'm just going to write a random example here. So you can just, if you want to write it down, find a little blank space or like a scrap piece of paper to follow along with, or you can rewatch this video whenever you'd like. So We're going to apply all those vocab words that we have to an actual parabola, okay? So remember, vertex is the turning point of the parabola. So as we go through this, maybe try and guess what the answer would be before I just tell you, so that way you're actively thinking about the problem, right? So here, the turning point is right here, right? It's where the vertex turns around. This point is 2, 4, right? So the vertex is at 2, 4. Easy. The axis of symmetry is the line that cuts the parabola in half. That will always go through the vertex, right? If you just kind of think about that logic. And there it is. Right? That's the axis of symmetry. Now, I'm drawing this in so you can kind of learn what I'm looking for, but you don't need to draw it in. That's unnecessary. It's just going to help you learn as you do it more. Now, it's always x equals some number, and that number in this case is 2, because that's where it is on the x-axis. So the axis of symmetry is x equals 2. Now, this parabola is increasing to the right of the vertex, right? If this was a graph of temperature, the graph went down, reached a low point, and then started going up. So it's increasing over here. So it's increasing when x is greater than 2. Now, it's decreasing over here, right? If this was a graph of temperature, that's when the graph is decreasing. So it decreases when x is less than 2. It's never increasing and decreasing. You shouldn't be using or equal to. I won't penalize you if you do, but at the vertex, at that 2, it's not increasing or decreasing. It's kind of like when you throw a ball up in the air, right? And it reaches a maximum height. It kind of stays there for just one moment in time, and then it comes back down, all right? Same idea. Now, the domain and range, the domain for every parabola is all real numbers, all right? I don't care how you write it, either way. And that's because domain only changes when you're breaking rules of math, when there's something that you can't input into an equation. For example, like if you input a number in and you were gonna divide by 0, or you would have to take the square root of a negative number, something like that, where you can't do that, all right? So in this case, you can square any number you want. So you can square all of the numbers, so all real numbers. There's an arrow pointing to the left and an arrow pointing to the right, if you want to think about it graphically. Range, there is a low point of this graph, though. It doesn't go up and down forever. So you think about the range, it kind of bottoms out right here. So y is always greater than, because it goes up from the 4, or equal to 4. And this is concave up because it opens up. All right, guys, thanks. Have a great day.